Hello students, hope you all are doing great. I know that you are busy in your daily schedule, but sometime you need to find out for your studies, and I hope that you are practicing the questions whatever are given to you. And regular practice is very important, as you all know that unless you practice regularly you won't find any kind of confidence. So to gain confidence you should practice the sums regularly. You should revise the topics, and this time we are going to do the last part of the chapter, that is motion part 6. Students, this time we are going to cover up uniform circular motion and examples of uniform circular motion, and after that we will study about a sample problem based on uniform circular motion. So this time we are mainly going to focus on uniform circular motion. Let us recall velocity and acceleration. It is very important to recall these two terms because we are going to use the concepts of velocity and acceleration to understand the concept of uniform circular motion. So what is called as velocity? Displacement of an object in unit time is known as velocity, or speed with direction is known as velocity. And acceleration, rate of change of velocity is known as acceleration. If the velocity of an object is changing, it means there is acceleration. If it increases, we call it simply acceleration. If the velocity decreases with time, we call it retardation. If there is no change in velocity, the velocity remains same, then we call that the acceleration is zero. Now, when does the velocity of an object change? So, the velocity of an object changes in three different conditions. The very first condition, when the speed of a moving object changes but direction remains same. Second, when the direction of a moving object changes but speed remains same. And third one is when both the speed and direction change. Means in three different cases or in three different conditions velocity of an object changes if only the speed of the moving object changes, then velocity is changing. If speed is not changing but direction is changing, then also velocity is changing. And if both the speed and direction are changing, in that case also velocity is changing. So this is very important to note about velocity of an object, right? Now, as because we are going to study about uniform circular motion, first you should know what is circular motion. So as you have learnt in your junior classes, when an object moves in a circular path, it is said to describe circular motion. An example, motion of earth around the sun. So I need not to explain this particular term for a longer time because you are already aware of circular motion. There are so many examples in our daily life, like motion of merry-go-round is an example of circular motion. Motion of moon around the earth is an example of circular motion. Motion of hands of a clock is also an example of circular motion. Now, let us see what is uniform circular motion. So, can you see that there are two different terms? First term is uniform and the second part of this particular term or the topic is circular motion. So, here uniform means we are talking about uniform speed. So when an object moves with uniform speed along a circular path, it is said to have uniform circular motion. So how to define it? When a body travels equal distances in equal intervals of time over a circular path, its speed is uniform. The motion of the body is said to be uniform circular motion. Example, we will be seeing the examples with the help of some pictures, but before that you should also know that the direction of motion at any instant of time along the tangent to the circular path at that instant. Yes, there is a new term, tangent. You must be thinking, what is this tangent? So let us find out. as you were told students that this is subject physics, and where you are going to study about so many new concepts, and you will be finding combination of concepts of physics, geometry and arithmetic. Okay, so what is a tangent in geometry? This term is usually found in geometry. In geometry, the tangent line to a plane curve at a given point is the straight line that just touches the curve at that point. The word tangent comes from the Latin word tangere, means to touch. In very simple words, tangent means it is a line which touches a curve or a circle just at one point. Let us see this figure. This red line, this is the tangent, because this red line is touching this circle at only one point, that is C. Let us see another figure. Here you can see this red line is the radius of the circle, and this red line is showing the direction of motion of the moving object, right? So this direction of moving object and the radius of the circle, they are forming 90-degree angle with one another, means they are perpendicular to one another. So the direction of the velocity of an object is in uniform circular motion is always tangent to the circle. They are always tangent to the circle. Like you can see this yellow object which is moving along a circular path, and at every point, first thing to be noted, at every point the direction is changing. Okay, at every point the direction is changing, and every time the direction of motion is forming a 90-degree angle with the radius of the circle. Now students, there is a question for you. Can you think of an example when an object does not change its magnitude of velocity? Magnitude of velocity means the speed. Means the speed does not change, but only its direction of motion changes. Right? Let us read the question once again. Can you think of an example when an object does not change its magnitude of velocity, but only its direction of motion change? So let us think, and here is an answer for this question. Let us see the first figure, PQRS. This is a rectangular path. It is a closed path like you can see in the figure. Suppose an athlete starts from point P and moves towards Q. So he changes his direction at point Q, and again he changes his direction at point R, then at point S, and again at point P. So how many times did he change his direction of motion? Yes. Yes, it is right. 4 times. Correct. Now, let us take an example of hexagonal path. In hexagonal path, how many times the direction is changed? If you count, it is 1, 2, 3, 4, 5, 6. So in hexagonal path, the athlete changes his direction 6 times. Now let us take an octagonal path. In an octagonal path means in a path where you have 8 sides, the athlete changes its direction 8 times, right? So let us see the next thing. What would happen to the shape of the track as we go on increasing the number of sides indefinitely? Earlier you have taken 4 sides, then you have taken 6 sides, and then 8 sides, and every time you have found that if the number of sides increases, then the number of change of direction also increases. Right? So if you keep on increasing the number of sides, then you will find the number of change in sides, number of change in direction also increases. So let us see, it is seen in the figure, like it is observed that as the number of sides of the track increases, the athlete has to take turns more and more often. So if you do this, you will notice that the shape of the track approaches to the shape of a circle, and the length of each side will decrease to a point. Like you can see here, now the length of side is simply a point. Okay, and when the object is moving along the circular path, at every point the direction is changing, and these arrow marks are showing the tangent to the circle. So if an object is located at this point, the direction of motion is this. If it moves to this point, the direction of motion is this. If the location is this point, the direction of motion is this. So this way it is changing, the direction of the object is changing at every point when it is moving around a circular path. So is the motion of an athlete moving along a circular path an example of accelerated motion? Answer is very simple, and yes, the answer is simply yes. Motion of an athlete along a circular path is an example of accelerated motion. Students, this is a commonly asked question in your exams. This is one of the most common questions which is being asked in exam, and you should know the answer. Why uniform circular motion is an example of accelerated motion? Answer is very simple. The direction of velocity vector at every instant is changing. So when the velocity changes the velocity of an object changes, it is said to be an accelerated motion. Here you can see, or you can imagine, the speed of the object is same, but direction is changing at every point. It means there is acceleration. Right? So this way you have learnt a new thing, that uniform circular motion is an example of accelerated motion, because the object is moving with same speed, means with constant speed, but at every point the velocity is changing. Now let us find out the speed of an athlete who moves around the circular path. So let us consider radius of the circle is r, time taken to complete one round, let us take it as t seconds. Now speed of athlete, formula of speed is distance upon time, so we can write a speed distance upon time. Now symbol of speed is v, and in place of distance we can write circumference of circle, because when the athlete is moving around a circular path, so one complete round is equal to the circumference of circle. So circumference of circle upon time, and formula of circumference of circle, as you all know, you have done in geometry, it is 2 pi r, and time is given by t. So speed of an object which is describing a circular motion, it is given by 2 pi r upon t. This is very important formula. Now let us see few examples of uniform circular motion. Motion of moon around the earth. It is moving with constant speed, but at every point the direction is changing. So it is an example of uniform circular motion. Second picture, motion of earth around the sun. You can see here the earth is revolving around the sun, and at every point the direction is changing. Though the speed is same, speed is constant, but direction is changing. So it is an example of uniform circular motion. Now, let us see an activity describing a circular path with a velocity of constant magnitude. Students, to do this activity, you need to take a piece of thread and tie a small piece of stone at one of its ends. Move the stone to describe a circular path with constant speed by holding the thread at the other end, like you can see in this figure. Right? This boy is holding a long thread, and one end of the thread is held by him, another end is tied with a stone. Now let the stone go by releasing the thread. Can you tell the direction in which the stone moves after it is released? If you carefully note, on being released, the stone moves along a straight line tangential to the circular path. You have learnt this thing in your previous slides. This is because once the stone is released, it continues to move along the direction it has been moving at that instant. This shows that the direction of motion change at every point when the stone was moving along the circular path. Now we have one example where you can see an athlete throwing a hammer or a discus in a sports meet. So when an athlete throws a hammer or a discus in a sports meet, he or she holds the hammer or the discus in his or her hand and it gives it a circular motion by rotating his or her own body. Once released in the desired direction, the hammer or discus moves in the direction in which it was moving at the time it was released, just like the piece of stone in the activity described just now. Right? So there are many more familiar examples of objects moving under uniform circular motion, such as the motion of the moon and the earth, as you have seen the pictures in the previous slides, a satellite in a circular orbit around the earth, a cyclist on a circular track at constant speed, and so on. So there are so many examples of uniform circular motion. Now it's time to solve a sample problem, and we are taking this question from NCERT book back exercises. Let us read the question. An artificial satellite is moving in a circular orbit of radius 42,250 kilometers. Calculate its speed if it takes 24 hours to revolve around the earth. So as I have told you earlier in your previous videos that whenever we solve any numerical, we need to write the given quantities at first. So let us note down the given quantities. R equals to radius of the circular orbit is 42,250 kilometers. Now time given here, it is 24 hours and speed you need to calculate. Then using the formula speed equals to distance upon time, and here the distance is basically the circumference of the circle, that is 2 pi r upon t, and this formula we have found few minutes ago, that speed of an object moving around a circular path, it is given by 2 pi r upon t. So let us put up the values. V equals to 2 multiplied by 24 by 7 multiplied by the radius 42,250 divided by 24. 24 hours is the time taken. So when you solve this, you will find 1.1 into 10 to the power 24 kilometer per hour. Students, if you want, you can calculate the answer in kilometer per second also. So if you want to calculate in the form of or in terms of kilometer per second, then you need to change 24 hours into seconds. How will you change? You need to multiply 24 by 3600 seconds, because 1 hour equals to 3600 seconds. So 24 hours equals to 24 into 3600 seconds. Here I have found the answer in terms of bigger unit, that is kilometer per hour. Right? So this way you can solve problems which are based on uniform circular motion, and it is very easy to find the answer. So again, you are advised to practice such kind of sums in your notebook. Written practice is very important, and you all are advised to use this time. Like you all know, time is very precious, and this way we are coming to the end of this chapter. Thank you everyone, and please like and share this video and subscribe my YouTube channel, and stay tuned.